Hey guys, for your warm-up today, go ahead and grab the half sheet off my table. You're going to need your pencil pouch and your calculator as well. What I want you to do is simplify these slopes and keep them as fractions. So if I look at the first one, 4 over 1, is there any number that can go into both the numerator and the denominator? Okay, the largest number here would be 1. So again, 4 divided by 1 would be 4. 1 divided by 1 would be 1. 4 over 1 would be my answer because again, I want to keep that as a fraction. Okay, the next one, negative 2 over 6. 2 goes into both negative 2 and 6, so negative 2 divided by negative 2 is negative 1. 6 divided by 2 is 3. I cannot simplify that anymore, so my answer here would be negative 1 over 3. Go ahead and do the rest as warm-up, and then when everyone's done, we'll push play to go over the answers. Okay, the third one, if you simplified correctly, you would have got negative 2 over negative 1. However, that's not simplified all the way, because remember when we divide two negatives by each other, okay, that ends up being a positive number. So your answer here should have been 2 over 1. Okay, the fourth one here is 1/2. My green line is negative 1 over 2, because both these numbers are divisible by 2. Then 1 over 1, negative 3 over 1, nothing happens there, it's already simplified. And the last one is 2/3. Okay, the next one, negative 12 over negative 4, simplifies to negative 3 over negative 1. Two negatives makes a positive, so my answer here is 3 over 1. Negative 2 over 1 doesn't change, it's already simplified. Next one's 2 over 1. And then this other one, I end up getting 2 over negative 1, which is correct, but I want you to get in the habit of bringing that negative just to the top number. So what I want to see is that negative 2 over 1 is your slope. Okay, the next two lines are 3/2, negative 1 over 1, negative 3 over 1, because again I want to move that negative to the top when I simplify my ratio, then negative 1 over 1. And the last line is 1 over 1, 1/4, 1/2, and negative 1/2, or negative 1 over 2. Okay, so again, we're going to be focusing on linear equations for a while now. Okay, that's the beginning of Unit 3, and we've focused on slopes to start out with. A lot of this is review from last year, so again, today's really basically a review day, and then tomorrow will be an assignment. So, on the next page in your journal, I want you to go ahead and label that 3-1, finding the slope. Today is October 3rd, 2016. Go ahead and head the page with the page number that you're on and fill out your table of contents, and Miss Osborne will come around and hand out to you the next half sheet, and it should say slopes from a graph notes. So we're looking at how to find the slope from a graph. Once you have that glued in and everyone's ready, Miss Osborne will push play and we'll start going over the notes. Alright, let's go ahead and get started. So again, we want to be able to find the slope from a graph. So let's go ahead and start off with what we know about slope so far. What we learned last week is another name for rate of change, if it's constant, it's the slope of a line. Okay, so rate of change and slope is the same exact thing. Because the rate of change is constant, which means it's the same for every single point, the difference between the y and the x values is the same, each part of that segment forms that straight line, and that's where we come up with linear. Okay, so it forms a straight line. Remember in our equation, y equals mx plus b, what part of that equation represents the slope? Okay, again, the m does. So we're talking about the m part of our equation for linear equations, which is y equals mx plus b. Because the slope is the same between each point, that's what makes a straight line. So what you need to remember is that the slope is the same thing as our constant rate of change, because that's what forms a straight line. And you'll also hear this word as the slope, the constant of variation. Okay, those all mean the same thing. Slope, constant rate of change, and the constant of variation. So let's talk more about the slope. The slope of the line is the ratio, or again, the fraction of the change in y values to the change in the x values. Now, why is it the change in the y values over the change in the x values? Again, y values go up and down, x values go left and right. So why do we go up and down first and then left and right? Well, if you remember from last year, you learned how to find the slope from a graph, and that was rise over run. When I rise, I go up and down. When I run, I go left and right. So that's why it's y values are the rise, x values are the run. It's always rise over run. Now the slope of the line also determines how steep it is, so it determines the steepness. Okay, the larger the number, the steeper the slope will be. Now I want you to add something. I want you to add an absolute value. It does not matter if it's a -5 or a +5. Okay, the negative aspect doesn't matter. It's still a very steep line. So looking at these three examples, it says circle the line with the biggest slope. Go ahead and take a second to do that, and then we'll discuss. Okay, you should have circled this third one, and the reason why that has the biggest slope is because it's the steepest. Okay, now this would be positive because it's going up from left to right, so it'd be a large number. Okay, the steeper the line, the larger the slope. So just to recap, what's important is the slope is the ratio, or again fraction, of the line's y values over the x values. Okay, and that's where we come up with rise over run. So let's talk more about the four types of slopes that we're going to be seeing. First two are very common. The last two, some students get those mixed up, but I have specific ways to help you remember. Okay, this first linear graph, okay, think about it as reading a book from left to right. If I read this line from left to right, what direction is it going? It's going up from left to right. So this is considered a positive slope. And the reason why it's a positive slope is because it's going up from left to right. The next type of slope we have, if I think about reading it from left to right, which direction is it going? It's going down. So this would be a negative slope. Okay, and the way we know it's negative is because it's going down from left to right. Now the next two slopes are what some of us get confused with. We have a horizontal line and a vertical line. Okay, so what do you think we call this horizontal line? Think about rise and run. Is it going up and down at all? No, it's just going really left and right, which is going left and right is a horizontal. Okay, this is called a zero slope. And the way that helps me remember that this is a zero slope, and please write this exactly like I do, is this horizontal line has a zero slope. So if you write down horizontal with a capital Z, you'll remember that since it has a capital Z in horizontal line, it is a zero slope. Okay, so that's an easy way to remember. A horizontal line has a zero slope. Now when I actually look at this as a fraction or a ratio, we didn't have any of this on our warm-up, okay, this would end up looking as 0 over a number. So it could be 0 over 5, which would be 0. It could be negative 0 over negative 5, it'd be 0. No matter what, when I plug in my calculator, my slope here will end up being 0. Okay, and then the last one, this vertical line, is an undefined slope. And one way that helps me remember an undefined slope is that this is a vertical line, so I'm going to make a capital V. And the vertical, or the V in vertical, looks a lot like a U sometimes when I write it fast. So that's what helps me remember. An undefined slope is a vertical line. Now a slope, the ratio for this slope looks like this, where it's the number over 0. Okay, now can you ever divide anything by 0? Let's see. So my calculator, if I do 5 over 0, what's it going to say? It's going to say error cannot divide by 0, and that works for any number. -2 over 0. It's going to say error. So whenever it comes to that as an error, you know it's an undefined slope. I cannot divide by 0. Okay, so again, just remember 4 different types of slope. We have a positive slope that goes up from left to right, negative slope, which just goes down from left to right, zero slope, and undefined slope. Now, which one of these 4 slopes, or linear lines, or linear graphs, is not a function? Think about that. Which one of these 4 is not a function? Okay, you should have said this 4th one, because remember, function, if I look at the vertical line test, all these points would be on this vertical line. So this undefined slope is the one that's not a function. And we'll get more into that later on. So, how do we find this slope from a graph? Okay, so it says when given a graph with a line, we need to know how to find the slope. So what we have to do is we have to use rise over run. And we learned from our notes earlier that it's the change in the y values over the change in the x values. And you'll see that triangle a lot used. Go ahead and put a big highlighter box around that information, because that's what's important. And we're going to look at the example on the right. So I have this graph right here. Okay, again, a graph, I want to figure out the slope of this line. Well, first of all, what type of slope is it out of these 4? It's going up from left to right, so I know this is a positive slope, which means my answer needs to be a positive fraction. So here are the steps we need to take. First step is pick 2 points on the line that intersect the grids perfectly. So they already chose 2 of them for me, but that's huge. You have to pick 2 points that are directly at the intersection of the grid lines. Don't pick some that are halves. We want to get the exact slope. The next thing is very, very important. We want to start at the point that's farthest to the left. I want you to write that, and then I also want you to highlight that. That's where a lot of my algebra students make mistakes, because it seems so easy to find the slope from a graph. We don't always start from the farthest left point. So to determine the farthest left point is if I'm looking at this graph, okay, I read the book left to right, I'm going to the point that I labeled first, which is this point. It's the farthest left point. So from here, I am going to do my rise. Remember, we do rise first over run because the y's come first. So I'm going up how many units? I'll go up 2 blocks, so I'm going up 2. Now if I go up, those are positive numbers. If I go down, those are negative numbers. Think of you sitting at the origin. If you go up the y-axis, these are all positives. If you go down the y-axis, these are all negatives. Okay? So since I have farthest left point, I'm going up 2. Okay, that would be considered my rise. So if I write it off to the side, rise over run, I'm going up 2. From this point, now I'm going to go run to the right here. So I'm going to go over 3 to the right. So I'm going to the right 3, which is again positive. Right is positive, left is negative. Again, think of yourself at the origin. If I move to the right, these are positive numbers. If I'm at the origin and go to the left, these are negative. So I went up 2 to the right 3. So my slope here ends up being 2/3. The slope of this line is 2/3. Go ahead and take a second to find the slope of this line. And when everyone's ready, we'll push play. Okay, first two steps is to find the 2 points on the line that intersect perfectly. I'm going to choose this point and this point right here. Those intersect perfectly. Okay, I know I have to use rise over run to find the slope here. So, from the farthest left point, I'm going to go up 2, which is a positive 2. And I'm not going to pick my pencil up, so I went up 2, and then I'm going 1, 2, 3, 4, 5 to the right, which would be a positive 5. So my slope ends up being 2/5. Okay? So one thing I also want to show you, and you don't have to write this down, is this is how sometimes students get messed up a little bit when it comes to rise over run. So don't write this down, just look up here. Say my intervals on my x-axis are going up by 1s, and my y-axis are going up by 5s. Okay, I'll go ahead and put some points, make a line, draw my grid lines. Now, I want to find the slope of this line that I drew. So again, I'm going to do my rise over run. 2 points are already labeled for me on the line, so I'm going to start with the farthest left point. So this is the farthest left point. Now, if I want to draw a right triangle to do my rise over run, I'm going to go up 1 unit. Now, I'm really only going up 1 unit, right? But look at the intervals. 5 and 10. I went up from 5 to 10, so how much should I actually go up by? I went up 5. So my rise here is plus 5, not 1. Okay, I went up 5 units. So we have to be safe and look at those intervals all the time. From here, for my run, okay, I'm going to go over 1 box, and I went over from 1 to 2. So I went to the right 1. So my slope here would be 5/1. So be careful when it comes to the intervals. You need to be very, very cautious as you're finding the slope. Okay, those are slopes from a graph. Next thing we're going to look at is slopes from points or coordinates. So go ahead, you're going to get this half sheet. Go ahead and glue this into the next page. When everyone's ready, we'll begin. Okay, so now we might not be given the actual picture of the graph. We might just be given points, sort of like the last 3 examples at the bottom, where it says find the slope of the line that passes through each pair of points. It's saying that these 2 points are solutions to the line. Okay, they are on that line. We need to figure out the slope just from these 2 points, even though there's lots of more points on that line. So this should be, again, review. There's a formula that we can use that will give us this answer very, very quickly. What I want you to do is flip to the inside cover of your journal to our formula chart. When you get there, we're looking at the section that says linear equations. Okay, we don't know what standard form is quite yet. We know slope intercept. We don't know point slope. But this right here should be familiar to you from last year. The slope of the line y2 minus y1 over x2 minus x1. Why do you think the y's come first over the x's? Well, let's see. Okay, so looking at our notes, okay, it says when given 2 points of a table, we can use that formula. Okay, so go ahead and let's write that down. Okay, so I have y2 minus y1 over x2 minus x1. And I want you to put a highlighter box around that. We use this formula to find the slope from 2 points. Now, why this formula? Well, remember what we just talked about for slope. remember, it's the change of the y values over the change in the x values. That's where they come up with rise over run. Okay, we always have to remember we take away the y's on top over the x's. That's where we sometimes flip these two, and that messes up the whole entire slope. It's always change in y's over the change of x. So let's go ahead and look at an example. Okay, again, I want to find the slope of this line from these 2 points. So the first thing I want to do, okay, again, these 2 points, any point on the line has the ordered pair x, y. So the first step is I'm going to subtract y value from another y value. In this case, I'm going to subtract the y1 from the y2. Go ahead and fill that in. Subtract y value 1 from y value 2. So when I write that equation, y2 minus y1 over x2 minus x1, I need to be able to determine which one's the first and the second y. Well, here's just an easy thing, okay? This is the first point they give us. This is the second point they give us. So in that case, this is my x1, y1, first point. This is my second point, x2, y2. So when I fill out this top portion, okay, my y2 here is 3 minus the y1, which is 7. I always put the second one in parentheses too, because sometimes that's a negative number. And then I also cross out the ones I used, so I don't use those again. 3 minus 7, y2 minus y1, which is 7. The next thing I do, okay, is I subtract the x1 from the x2. So again, y2 minus y1 I already did. x2 minus x1. x2 is negative 2 minus x1, which is 1. Okay, and then from there I'm able to solve. So again, I can use my calculator to minimize errors. 3 minus 7 is negative 4. And negative 2 minus 1 is negative 3. Now from our warm-up, remember whenever I divide two negatives, that makes it a positive number. So my slope here is 4/3. Okay, simple as that. Now there's a little thing right here. Remember, if this was like a negative 1, negative 2 minus negative 1, whenever there's two negatives together, we have to switch those into an addition sign. So always remember that. That's why we put the second one in parentheses. Okay, what I want you to do is take a couple minutes to work on the next 3 by yourself, and then check with your neighbor to see if you got it correctly answered. Okay, this first question, 6 and negative 1 and 4 and 2, these 2 points are on the line. What's the slope? What I expect to see for every single one of these problems is you labeling your x1, y1, and x2, y2, and I want you to write down the formula every time. y2 minus y1 over x2 minus x1, and go ahead and, for every single one, do that. Okay, and then solve it. When everyone's done, we'll push play to go over the answers. So if I continue with this first one, I went ahead and labeled the y2 is 2 minus the y1, which is negative 1, so I use those two, over x2, which is 4, minus x1, which is 6. When I simplify this, 2 negatives makes a positive, so I'm left over with 2 plus 1 over 4 minus 6, which simplifies to 3 over negative 2. So my slope for this first line that passes through these points would be 3 over negative 2. Okay, the next one, y2 is negative 2 minus my y1, which is 3, over x2, 3 minus 4. I'm going to go ahead and simplify that. Negative 2 minus 3 is negative 5. And 3 minus 4 is negative 1. Two negatives divided by each other makes a positive answer. So my answer here for the slope is 5 over 1. And then the last one, y2 is 1 minus y1 is 7 over x2 negative 3 minus x1 negative 1. Notice that's why we put it in parentheses, the second number. So the top portion, y2 minus y1, 1 minus 7 is negative 6. For this bottom one, remember 2 negatives makes a positive, so I'm just going to go ahead and switch that to a positive. Negative 3 plus 1 is negative 2, which simplifies to positive 3 over 1, because 2 negatives makes a positive. So your answer here for these three questions are 3 over negative 2, 5 over 1, and 3 over 1. Again, this is how we find the slope from 2 points. Okay, and the last thing we're going to talk about today is slope from a table. So again, you're going to get a half sheet, glue that into the next page, and when everyone's ready to start, we'll begin. Okay, so 5-1, we are finding the slope, this should be 3-1, slope from a table. Okay, so again, if I give you this table, I don't give you points, I don't give you a picture, I don't give you a graph, okay? I just want you to find the slope from a table. So these are the steps that we need to take. Pick any 2 points from the table. So let's pick, for instance, this point and this point. They don't need to be next to each other. They could be the first and the last point on the table. They could be next to each other. It doesn't matter. Any 2 points on that table will work. Okay, the next thing we want to do is find the change or the difference in the two y values. Now again, we always do y values first because of the rise. Okay, when we do that, we put our answer at the top of the ratio. Next thing we do is find the difference between the x values, and those go on the bottom. Because again, we're doing rise over run, or the change in the y values over the change in the x values. So remember, always y's over the x's. So let's go ahead and use this method. Okay, again, if I want to do the change in the y values first. Okay, I'm going to pick these 2 points that we already chose. What's the difference between 3 and 9? What happened? 3 and 9. I went up how much? I went up 6, so that's a positive 6 for the change in the y values that I chose. The x values that I chose, what happened from 2 to 6? I went up 4. So when I look at my slope, 6 over 4, does that simplify to anything else? It sure does. It simplifies to 3/2. Okay, so 3/2 here would be my slope, and I could choose any points. Think about this first 2 points, 0 to 3, the change in the y values. What happened? I went up 3, which would be the top. Okay, the change in the x value, 0 to 2, went up 2, so my slope here would be 3 over 2. Now there's actually another way we can solve this. Let's save these 2 points again. Another way of writing these 2 points is if I just list them. 2, 3 and 6, 9. We just got done figuring out the slope from 2 points that are written like this. So if you recall, what's the formula we use? y2 minus y1 over x2 minus x1. Okay, so I'm using this formula from these 2 points. Again, it could be any 2 points given to us from the table. Label my x1, y1, x2, y2. And I'm going to go ahead and fill in what I know. So y2 is 9 minus the y1, which is 3, over x2, which is 6, minus x1, which is 2. So when I go ahead and solve that, 9 minus 3 is 6, 6 minus 2 is 4, and that simplifies to 3/2. It gives me that same answer that I found by looking at the change in y over change in x. Okay, go ahead and take a couple minutes just to work on these last 3, and then when we're done, we'll go over and discuss these. Okay, so let's look at this first one. I chose the first and the third point. Doesn't matter which ones you chose, we should end up getting the same answer. So, If I look at the change in the y's, 3 to 7, I went up 4. And the change in x's, from negative 2 to 0, it went up 2. So I'm left over with 4 over 2, which ends up simplifying to 2 over 1 as my slope for that first graph, or for the first table. The next one, change in the y values. From 10 to 5, I went down 5. X values, negative 5 to a negative 2 is a positive 3. So I'm left over with just negative 5/3 as the slope for the second table. And the last one is a horizontal table. So again, changes, the y's are at the bottom, x's are on the top. So changing the y values, okay, from 23 to 43 went up 20. And from the x values, 5 to 10, it went up 5. And 5 goes into 20 4 times. So my slope here for the third table is 4 over 1. So hopefully you got those 3 correct. If you did, great job. If not, we're going to have some more practice tomorrow, and then you'll have an assignment tomorrow. So make sure you look over these notes tonight. There's no homework, and we will see you tomorrow. Have a great day.